name is Karla Palos. I'm a research associate at the California Policy Lab. And today I'm joined by my wonderful colleague, Sarah.
Hi, I'm Sarah. I'm also at the California Policy Lab.
So today we're going to be talking about hash linkages for administrative data sets. As Grace mentioned, the structure for today is going to be a little bit of a lecture style. We're going to have a couple sections where folks can ask questions. Given the amount of material that we want to cover today, we might not get through everyone's questions. If this is the case, feel free to shoot us an email or catch us after this lesson, and we'll be happy to talk over anything. The second point that I want to make is that this presentation, the toolkit code, and all of the material that we have is the outcome of a lot of work from different members of our staff over many months. Even then, there's still a lot of work in progress. So if by the end of the session you have feedback for us or suggestions, feel free to let us know. We always look for ways to enhance our toolkit so that other folks can continue to use it. And the last thing that I want to mention before we begin is don't feel the rush to write notes. We're going to provide you with all the material. So yeah. So with that, let's get started. The agenda for today, we're going to do a hash linkage overview, go more in depth about hashing and then do an activity, go in depth about linkage and then do an activity, and then finally some takeaways and resources. So let's begin with what is the California Policy Lab. The California Policy Lab is a non-partisan research institute at the University of California. We have two sites, one at UCLA and the other one at UC Berkeley. And our mission is to improve the lives of Californians by generating evidence that transforms public policy. We focus on 6 different policy areas, including social safety net, higher education, criminal justice, labor and employment, homelessness, and health. We work with over 40 state and local government partners and focus almost exclusively on administrative data. And as you can see, we currently have data on wages, taxes, unemployment insurance, human services and homelessness systems of enrollment, and more. Before I jump into the hash linkage piece, I want to give you a little bit of a motivation as to why we do this. So say you're interested in answering a research question regarding a specific program, say CalFresh or the Supplemental Nutrition Assistance Program here in California. To answer, I don't know, a question about the characteristics of the enrollment, you might want to look at the data from this specific agency, so the Department of Social Services. But what if you were trying to answer questions regarding, I don't know, like the impact of CalFresh on employment, or the impact of CalFresh on health, or the impact of CalFresh on education? In order to answer this question, it will require us to link data of different agencies. Although we're not really touching the part of the hash piece right now, just keep this in mind as we move through the presentation. So what is hashing and why do we do it? We're going to begin with a couple of definitions. The first one is hash linkage. A hash linkage is a way of joining 2 or more data sets that typically contain personally identifiable information that we wouldn't be able to see for a number of reasons. Some example of this PII is, first name, last name, date of birth, social security, phone numbers, addresses, etc. Hashing is a method of turning readable data into unique but unreadable data via a one-way encryption process that cannot be reversed. And it does this in a way that it allows us to distinguish 2 unique values without actually being able to see that information. So the way the hashing works is that if you have 2 values that are the same before they're hashed, after you apply this hashing algorithm, they should have the same hash value. If you have 2 values that are different before they're hashed, after you apply this hashing algorithm, they should still be different. And this is what actually allows us to link the data in a meaningful way, which takes me to my next point, linkages. So a linkage is what allows us to identify an individual or data across different data sets who we believe is the same. In the context of this presentation, with the added constraint that we cannot actually see the underlying information. since we're applying this hashing in a standard way across all of our partners, we're able to actually link this data, again, in a meaningful way. So in here, you can see the power of hash linkages. It allows us to break down policy silos, data silos, research silos, and policy silos. So I'm gonna begin with a very general case. You have two agencies, each of them has PII, and they're not able or don't wanna share this data with each other or anyone else. And this could be for a number of reasons. It could be that they don't have the technical capacity to do so. It could be because of privacy or security concerns. It could be that they have never worked with each other before, they don't have a good relationship, and they don't really have the trust to do so yet. But very frequently, the reason is due to legal constraints. So let's imagine we overcame that phase in which they cannot link the data, and two agencies are actually able to do so. You have two agencies, they have their PII, they encrypt their data, and then they're able to do this linkage. In the context of what we're going to be speaking today, it requires for the partners, for the agencies conducting this linkage to do so via a third party. So even when agencies have the ability to hash their information and link that information, they might be able to do so only if they do it via a third party agency. And what we're going to be talking today, CPL serves as that trusted third party intermediary, helping the agencies hash their own data and ultimately facilitating that linkage. In here, I want to take a second and just say that hash linkages are not always the only solution, are not always even the best solution. If two agencies can just link their information, their identified information, that is a great way to go. If they can hash their own information and link their own information, that's also a great solution. However, very frequently, because of those legal constraints that I talked about, they're only able to do this if there's a third party facilitating that linkage for them. So I'm gonna talk about a brief case study of a project that we did here at CPL a couple months ago. So the Department of Social Services expanded the eligibility for their supplemental nutrition assistance program, which is called CalFresh here in California, to include students that had an expected family contribution of 0 in their financial aid applications. And this was in response to the COVID-19 pandemic. A second agency, the Student Aid Commission, ran a randomized control trial to test the outreach, informing the students of the new eligibility, and encourage them to apply to CalFresh via a simplified online portal, which was getcalfresh.org, which is administered by a third agency, Code for America. The main question we were trying to answer here was, does outreach to college students who are newly exempt from the CalFresh student eligibility rule due to having a 0 EFC in their FAFSAs induce them to apply to CalFresh and ultimately get enrolled? We can think about this question as a three-party linkage. So the first, we have California Student Aid Commission, CSAC, which has all of the information of the students who were eligible to under this new rule and who were notified. We linked this information to Code for America, which had information about the individuals who applied via this portal. And then finally, we linked this to the Department of Social Services, which had information about enrollment. So keep this frame of mind as we move through the presentation. Going back to the earlier diagrams that I showed you, I'm just gonna show two here for simplicity. We have CSAC and CDSS. Each of them have their PII. CPL helped them hash their own data, and then we facilitated the linkage for them. And this is what allowed us to actually get our research project done. So, so far you have heard me talk a lot about hashing. So let's talk about what actually hashing is. So the hashing technique applies a hashing algorithm. At CPL, we use a SHA-256. We apply this algorithm to our PII, and the example I'm showing here is the SSN, and it produces a unique hash value. So it's a string of data that is no longer identified, just a bunch of numbers and letters. And it has two important characteristics. The first one is that it doesn't allow for collisions. So what this means is that two unique original values should never produce the same hash values. Otherwise, it could produce this could introduce false positives. So in the example we see here, we have two SSNs that are almost exactly the same. There's only a small difference at the end. One has a 9, the other one has a 0. And if we look at the unique hash value that it produced, they are completely different. So we can think about the corollary of this to also hold. So if two agencies have an individual named John in them, if we apply the same hash algorithm, we should expect John to be hashed exactly the same way between the two of them. The second important characteristic is that it's irreversible. So since we're applying this one-way encryption process, this means that there's no deterministic way to back up that information, even if you know the hash value and you know the algorithm. Otherwise, you really wouldn't be able to protect the privacy of individuals. In here, I want to make a small note. So at CPL, we decided to use SHA-256 because, again, it's property, so no collision and being irreversible. It's also an cryptographic industry standard. We're not necessarily tied to this algorithm in our code. If in the future we realize that it's no longer serving our purposes, it could easily be adapted. Okay, so on the previous slide, I mentioned that there's no deterministic way to back up names. But you can imagine someone trying to, maliciously figure out who is in your data, trying a bunch of different hashing algorithms. They know that there's a John in your data. They find one there, and they can try to back up names this way. So in order to try to mitigate the risks of guessing inputs, we add a second layer of security into our hashing, which is called a salt. So a salt is a string of text that is added to the PII before it is hashed. And the example that we're seeing right here, the salt is I love apple pie. And as I mentioned earlier, even changing the smallest input will produce a completely different output. So if we attach this string I love apple pie to our SSN, it's gonna produce a completely different hash value. Some of the things that you might be wondering is how do you pick a salt? It's like a password. You want to get something that is alphanumeric, something that has many characters. So the longer it is, the stronger it's going to be. I think ultimately it doesn't really matter what you end up picking as long as all the partners who are hashing their data are using exactly the same salt. And the reason is, again, you don't want a partner to hash with I love apple pie, the other one hash with I love apple pies, because otherwise you're never going to be able to link that information. Okay. So now let's talk about how we put a hash into operation. These are our general steps. The first one is get the legal agreement, so the DUAs and IRBs in place. We're not going to talk about this today. Just know it takes a long time and a lot of effort. The second one is put a data request. So in here, it involves identifying the partner staff and assemble your data request requirements. We're going to go a little bit more in detail in a couple slides. The next one is interview the partner staff on the environment and the data. So this is not something that we were doing originally. And after a lot of iterations, we realized that it's a very important step that will save us a lot of time when we're doing the hashes and the linkages. The next one is modify the code if needed. So at CPL, we have publicly available the hash code in SAS and in Python. If you feel like you need to modify that or create any new language, by all means, that's an option. The next thing is work with a partner to hash the data. And this consists of 3 main steps. The first one is the salt. The second one is testing the salt and the caching code using a synthetic test data set. And this is an extremely important step, and we're gonna talk about why this is in a second. And then finally, hash. We also added a 6th point, which is troubleshooting common issues. They come up more than what you can imagine. We don't actually have a slide on those common issues, but if you wanna talk about, those stories, we'll be happy to chat after the talk. So in here, I just put a general timeline. This is a very optimistic timeline. In here, it takes you like roughly 9 to 12 months to finish a hash from beginning to end. But like I mentioned, this is a very complex project. There's a lot of things that can go wrong, like throughout it. Like even with the hashing, which tends to be the shortest component. In here it says 1 to 2 weeks. We had instances where it taken us more than a month because of different issues. So the recommendation for project managers is to build a lot of time into your timelines to accommodate for these different things. Okay, so now into working with the partners. The first thing that you want to do is identify the correct data and hashing points of contact with the project manager. So the person who's pulling the data for you might not be the same person who's hashing it, might not be the same person who is sending the data back to you. So knowing these points of contact ahead of time can save a lot of time. You might have to explain the same process multiple times, so just account for this when you're thinking about the hash linkages. The next thing that you want to do is put together an explicit data request. And this point is underlined because I cannot express how important it is. The last thing that you want to do is to hash a bunch of information and it not be the data that you actually need. So an example of the universe, that we might want to get is all the CalFresh applications that were started, but not necessarily completed or submitted between January 22nd to December 22nd via the getCalFresh.org portal. So when you send the data request, you want to be very explicit about like the time frame, what variables you're requesting, including the program data, what variables you're going to be requesting. For instance, if you're including phone numbers, be very explicit that needs to be hashed. The gathering requirements. This is what I referred to in the earlier slide as having an interview with a partner. So in order to try to minimize the amount of like back and forth that you're gonna have, and especially because you are helping someone hash information that you cannot actually see in their computers, and you're doing a lot of like troubleshooting, it's very important to try to get as much information as you can before you begin this process. So as I mentioned earlier, we have the hashing code in Python and SAS, identify what languages are gonna be using. Some partners in the same project might hash in Python, and other might hash in SAS. So like be on the lookout for those things. The other one is account for machine and environment constraints. So we actually had a partner who typically hashed in SAS, and they used to do it in base SAS on their desktop. At one point, they switched to do it on the cloud. We didn't actually know that this had been the case. And it took us a couple of weeks to try to like figure out what was the reason why things were not working the way we wanted them to work. The next one is ask the partners how they're storing, formatting, and cleaning data. So things you want to know is like primary keys, is the PII distributed across multiple CSVs or whatever like format they're storing their data? What is the delimiters? Are they encoding the special characters in any particular way? This has been, believe it or not, a major issue with trying to hash with different partners. Another thing is like, are they doing any character substitutions before it gets to you? Do they have any placeholders for missing data? So for instance, if a partner puts 9999 on a missing field, you don't actually want to hash that value because once it's hashed, you cannot actually see what the value behind, what is the actual real value behind that. So you want to know these things before you begin this process. We also put quoting. We can go more in detail if that's of interest to folks. Essentially, if you don't know what this is, it might cause like differences in the amount of records that it's reading when you're trying to hash the data. And then finally, again, preview the hashing process with them. The next part that I want to talk over is defining the roles and expectations. So I talked earlier about the salt, which is, this special key that the partner should choose so that you can hash the data in a very secure way. I think the main takeaway at this point is that you, the trusted third-party intermediary who is facilitating the linkage, you should never know what that salt is. You don't know how they chose the salt. You don't know where they're storing it, and you should never know any of these things. All you need to know is that hash meeting happened and that they're ready to go. The next thing is test the salt and the hashing code. Again, I underlined this. It's really important. We're going to go over it in the next slides. The next part is go over with them what is a caching process and any code modifications. So in the code that we have written, they should only change the input file path, output file path, include the salt and any variables that they're going to be hashing. And then finally, how to transfer the data back to you. I don't think I need to say this to y'all, but don't send data via email, right? Like try to figure out a secure protocol to send the information back to people. You're trying to minimize inadvertently exposing people's information. So the scenario that I'm talking about here with testing the salt and the hashing code is the following. The partners already had agreed upon the salt. They have the hashing on their machines, the hashing code on their machines. They have already pulled the data and they're ready to go into it. Because we cannot see, again, the data that they're hashing, we don't know anything really about their code. We cannot see the salt, we cannot see the PAI. What we're trying to do is include as many quality assurance checks as we can before they even begin hashing. The last thing you want to do is have someone hash a million records and then realizing that it was hashed incorrectly. So what we do in this step, before they jump into doing the full hashing, is we send them a small synthetic test data set. I'll go over what are the requirements that we put for this example in a second, but we send all the partners exactly the same test data set. And we ask them to hash it with the code that we sent them with the salt that they pick. And the reason that we do this is that if there's any issues, for instance, with the salt, say one partner hash with, I love apple pie, and the other one with I love apple pies, we will be able to catch that really quickly. And the reason is that we send them this data set, we ask them to send back that information to us, and then we try to see if it actually matches. This is the only instance where we all know the input and we all know what the expected output should be. So this is the reason why we do this step. The other part that we're checking is, again, the code. If we know that the salt is working, all of them are using exactly the same salt, we're 100% sure of that, and we're still getting something like this, that not all the records are matching, it's probably due to something in how their machine is handling the code. And this is an example of what I mentioned earlier with the SAS, that with one of our partners, we realized that it was not handling special characters properly because their SAS studio was handling different than the base SAS. Okay, so anyway, after all of the partners have sent us back this information, all of this is actually green boxes that say match. Then we give them the green thumb, and they're ready to actually do the full hashing. This is an example of a synthetic test you might want to send. We go by a couple of rules. So the first one is keep it short. You're not actually testing your hashing code with them for the first time. We're testing that it works on their machine. So you don't need more than 10 rows to actually figure this out. The second thing is test for edge cases. So in here, we included numbers in the first and last name. We included a couple empty spaces. We included special characters. On the social security, we also purposely put invalid SSN. So like the first record is 1 through 9. That's an invalid SSN. We also put missing SSNs or shorter SSNs. In the date of birth piece, we also put out of range dates and also dates that are formatted incorrectly. So the last point that you want to address when you're creating a synthetic test data set is to test all the variables that you're going to be hashing. I think that's kind of obvious, but in here we're doing first name, last name, social security, and date of birth. If you're adding addresses or phone numbers, make sure you account for that as well. Okay, and with that being said, I'll pause before I finish this slide. Are there any questions? Yes. That is a great question. The way that we typically set it up is that we ask a representative for each of these organizations to get together in a room. We go over the instructions and they decide on a salt. So and this is how we like ensure that we don't know it. In regards to how they save it and how they ensure that this is passed down by individual to individual when people leave the organization, I don't have the best solution for this yet. Well, this is something that we recently actually encountered with one of our partners, an individual who typically did this hashing process left. So they didn't know exactly what was the salt. We set up again a meeting with the members of the other agencies that usually hash, and they went over with them and shared that salt with them. I think this is a little bit more on the end of the agencies who are hashing the information, because again, we don't have any control over that part. But that is really a great question, and I really hope that we find out a great standard solution for all of our partners soon. Other questions? Okay. Yes. Yes, that's a great question. I think it depends on the project. So for instance, with some of the projects that we work, we typically receive data updates from that partner every couple months. So you don't want to be changing the salt all the time because it will mean that they will have to rehash everything that they hashed in the past. So we do have projects that are like just a one-time thing and that's it. So that's fine. Like after that point, they can discard that salt. But with other projects that send us data regularly, like they have to know what that salt is to continually hash on that. So we're not actually gonna go over the hashing code, but I'm gonna tell you what our code does. The first thing that it does is that it normalizes the data. So it converts everything to lowercase, maps any values, removes white spaces, removes punctuation, it standardizes special characters. The second thing that it does is that it chops up the data. And this might sound a little bit weird right now, but essentially we're creating partials of the PII. So say for instance that two agencies hash their data. My last name in one of them is Palos, and the other one, my last name appears as Palo. Because the values have been hashed, there's no way, first of all, they're not gonna match. And there's no way that I can actually note that they're not matching because one of them has an S and the other one doesn't. So in order to give us a little bit more flexibility when we're linking the data, we create partials of that PII. So for instance, with the last names, we tend to take the first two letters and first four letters. We also do something similar with the SSN. And Sarah's gonna go more in detail as to what exactly we do there. But the idea here is that if Palos, my full last name, didn't match on both agencies, maybe the fourth letter, which is not as accurate as doing the first one, but the fourth letter might actually match between the two agencies. And actually, I put a small example of that here on the back. If you see here, SSN, we create a bunch of partials for the SSN. But anyway, Sarah will cover that in more detail. The next thing that we do is that we apply the salt to the data. So all of the regional PII and all of these partials that we're creating. And then finally, we hash all of this information. Okay, so with that being said, I'm gonna pass it over to Sarah so that she can do a small interactive activity. Yep.
Thank you so much, Carla. And everyone should have gotten an email from Grace with a link to a Jupyter notebook. So feel free to go ahead and open that up. This is just an example using some fake made up data sets of why it's important to follow all of the steps that Carla outlined in her previous slides when hashing the data, and how even one thing being off can throw off the entire operation. So this is just you don't actually need to write any code. It's all there written for you, and it should be able to run in JupyterLab. And I'll show you, I'll pull it up on my screen as well, just to show you. So you should see something like this if you're able to pull it up. And then under notebooks and hashing is where it should be. And are you all seeing this? Yes? Yeah, I was worried that might happen. The link seemed to work for me, but that's okay. We have it up here, so I can basically keep it up on the screen for you guys and kind of scroll through it. So, but basically, this will show you, and I'll leave it up and kind of periodically scroll down for the next few minutes so you guys can sort of read through it, and we'll make sure this gets sent out properly at the end so you have access to it as well. But we have two data sets that are in this example, and it will just walk through some of the steps. So I'll keep this up here for now. Feel free to read through it, and I'll kind of just scroll down so you guys can oh yeah, yeah. I don't know if it can go any bigger. Let's see. That's a little too much. Is that better? Awesome. And if I'm scrolling too fast, let me know. And feel free to ask questions as well. Yes. Okay, awesome. Yeah, I'll send you guys I guess I don't know how to send it out. But this is also on GitHub. But I'll scroll. I can maybe even put it in bigger. Yeah, so it's California Policy Lab / hashing exercise. Okay, awesome. Good idea. Yeah, and it should already be run, so you shouldn't need to download it or anything. Yep. Everyone good with the GitHub? Awesome. We'll also just go around and let us know if you have questions. All right. I think we're gonna come back here. Thank you everyone for actively participating and for your great questions. I think kind of the main takeaway from that exercise is that once something is hashed, there's no way to go back, right? So all of the cleaning and the standardization and anything else that you want to be doing to make sure you're able to find matches kind of needs to happen ahead of time. And we'll go over more detail around this as well. But there were lots of great questions, and I'm sure you guys are already thinking about all of the challenges that are associated with that. Are there any final questions before we move on? Oh, yeah.
So thank you for the individuals who asked questions. There was a point that I want to make. When we're actually doing the linkage, we don't see any of the original PII. So we don't see, like, if my name is Karla, I'm never going to be able to see that the name Karla and the actual linkage. You only see those strings of variables, of values that you produce via the hashing. So with that in mind, I'll pass it back to
Yes, and that is an excellent point. And with that, so now we've gone over hashing, all of the various challenges that can come with that, and we'll dive into what do we mean by linkage and how do we actually link data after it's been hashed. So fundamentally, the problem we're trying to solve is how can we identify who is the same person across administrative data sets. So imagine an example where we're trying to link data from two different hospital systems about patients in those hospital systems. How can we identify the same person when we're not able to see the PII? And the solution that Karla alluded to in the first half of this presentation is that we first hash the data so we can't see the underlying values and then try to link. And one important note I want to make here is you can see in both Hospital A and Hospital B, we have an identifier column. Oftentimes in administrative data sets, they may come already with an identifier that tells you who is a unique individual in that data set. But since that's not going to be consistent across various systems, we can't use that identifier to match with the other agency. So we rely on the personally identifying information instead. And so in this example, we've kept the hashed values and the underlying values side by side. And you can see we have Ruth and John who look like they might be the same person. And in practice, we would only see those hashed values to identify who's the same across these data sets. So, oh, yeah. Mm, mm. Yeah, absolutely. So that's a challenge that comes in kind of ahead of the whole process when we're working out the legal agreements and the DUAs. And that's absolutely a whole other challenge and part of this as well. So you do need both Hospital A and Hospital B to be fully on board and fully understand what's going to happen to their data beforehand. So all of that is kind of part of the initial agreement ahead of time. Does that answer the question? Awesome. Okay, so the most simple version of this is we just take the identified information that we have. So for example, first name, last name, take the data as it is, hash that information, do a join just on that hashed information as it is and create what we call a crosswalk, which is going to be a mapping of those identifiers that I mentioned in the previous slide, where we say 1, 2, 3, 4 in hospital A is the same as 4, 5, 6, 7 in hospital B. So in the previous example, we can't actually see the underlying information. This is a closer approximation of what it would actually look like. We see, okay, first name, last name here matches first name, last name here. That's a match. Same with these two as well. And ultimately, our crosswalk is going to be just the matches that we have. And we say that these are the identifiers that match to each other just based on the PII. Oh, yeah. Absolutely. Yeah, so we'll go over, we have a whole strategy for how we do that, and we'll go into that as well. But as you all know, working with data sets and administrative data sets, especially, the data are often imperfect. So again, imagine we're linking hospital records. Do we really think all of the true matches are going to be perfect matches? And I think the answer is probably no, right? Someone's last name may change. There may be nicknames like John versus Jonathan, or if we're thinking specifically about the hospital example, think about the context in which the data is collected. You might have a physician who's running to their next appointment who has to quickly type up their patient notes. So all of these are reasons why we might expect variation in the data. And so in this example, we have Karla with a K and Karla with a C. So we know Karla. We think these are really the same person, but if we just hash the data as it is, we wouldn't see a match. And so that's why we try to use our own version of a fuzzy matching. So in situations where we're not using hashed data, fuzzy matching is typically some version of a string distance where you say these two things are close enough. So in the previous example, Karla with a K and Karla with a C have a string distance of 1 because you only need to do one string substitution to get from one to the other. And in some cases, we can come up with a set of rules to determine what we think is close enough to be determined to be a match. However, as you probably imagined from the previous exercise, this can be challenging once we introduce hashing because we can't actually analyze those relationships once something is actually hashed. So what we do instead is we create subfields from the variables that we'll be hashing and hash those, and so that we can compare the subfields to each other. So for first name and last name, we typically will do something like the first letter or the first 4 letters, pull that out from the data before it is hashed, hash all of these things, and do that comparison. So in this case, we don't see a match just looking at first name alone on Jonathan and John, but once we look at the subfields, we're able to identify that this could potentially be a match. So in most cases, we'll have the following 4 fields from administrative data sets. This isn't necessarily always going to be the case, but this tends to be a pretty common list. We'll typically have social security number, first name, last name, and date of birth. So for the first name and last name, we'll take either the first letter, the first 2 letters, the first 4 letters, hash those values separately. We'll also do what's called a soundex, which is a phonetic transcription. So the soundex for Karla and with a K and Karla with a C should be the same because they're pronounced the same. For Social Security, if you got to the end of the exercise, you'll see how this looks in action, but we'll take two pairs of consecutive characters from the Social Security, remove those, and hash what remains, which will allow us to see if there's a typo or something in that. And for date of birth, we will hash separately the day, the month, and the year. So looking at another example, we see we have the first letter as well as the first four letters, and the last name are all the same. And we can see this even though there's no relationship in the first name. But do we think this is really close enough to be considered a match? And in this case, we were maybe expecting to see something like Samantha and Sam, which could be the same person. But seeing the actual underlying values here, this looks like it's maybe not actually a match. So how do we account for that? We have our own set of rules and criteria that we will create for each linkage to determine what we think is a strong enough match. And we call the set of criteria a matching round. And for each linkage, we'll typically have multiple matching round. So an example of a matching round is just a perfect match on all of the fields that you have available. Another example might be a perfect match just on Social Security and two of first name, last name, and date of birth, and a fuzzy match on the third. So a fuzzy match would be, maybe it's not a perfect match, but something like the first four letters or one of those subfields actually matches. And you can think of any number of ways that we can come up with a matching round. And another thing we will look at is the scoring. So in the example of first name, we probably think the first four letters being the same is a stronger indication that this is a match than just the first two letters. So scoring is how we differentiate between those two things, because those would still both be a fuzzy match, but we do want some way to sort of evaluate how strong we think that match really is. So typically a perfect match on the full field would be given the highest score. And in the example of first name, we'll maybe do combinations of some of the fields. So match on sound X and the first four letters is the next highest. And we keep going and rank those sequentially. And each field on its own is not enough to make a determination. We have to evaluate the information in the context of the other information available to us. So a match on date of birth alone isn't going to tell us much, but if we match on date of birth as well as Social Security, that is a much stronger indication that this might be the same person. And now we'll get into how we assess the quality of our resulting matches. This is a pretty challenging problem. If we were able to just identify who was the same, had some sort of benchmark, we would just use that. So the whole point of this exercise is that we don't have any ground truth to work off of. So one approach is to go back to that unhashed identifier that I alluded to in the previous data set. So if we have one identifier in agency A that is getting matched to multiple identifiers in agency B, well, we think those identifiers in agency B are really a single person. So that means we have one person in dataset A getting matched to multiple people in dataset B. So that actually means there's probably some sort of false positives going on there because we really think those are separate people. And another thing that we've evaluated is just which rounds that the matches tend to be found on. So in our experience, most of the matches will come from the first round, which is going to be the strictest round. And then as we loosen up criteria as we go along, we get some additional matches, but that marginal match rate goes down each time. And that's a pretty good indication that we're on the right track. If we all of a sudden see that marginal match rate spike when we're adding a new, when we're loosening some of our criteria, that could again indicate some false positives. And now we'll go into just some things to be thinking about as you're determining your own linkage strategy. So as Karla mentioned, we first start by doing all of the legal relationship management groundwork, very important. And then when you start to actually develop your linkage strategy, you'll first want to think about what fields are actually available, the definitions of what is considered bad or invalid data, and then go into your match scoring and matching rounds. And it's important to be thinking about all of this before you actually hash the data, because you'll need to know what partial fields you want to be using ahead of actually hashing. And then once you have the data, you have your strategy, you can implement the code and run that. So I'll go over just what we mean by the PII inventory. So the first thing is just to determine what information do I have that's common in both data sets. So if I have Social Security in one data set but not another, I'm not going to be able to use that to link. And once you have the actual list of fields, you also want to be thinking about the quality of those fields and how much you trust it. So if Social Security is missing for a large portion of one of your data sets, you probably don't want to rely on that as the only thing you're matching, because then you'll never be able to match 20% of the data set. Another thing to think about is just how the agencies are collecting their data. In Karla's example, where there was a portal where people could log into, that might be an example where someone's typing in their own information. It's not validated. There's room for typos. Versus if we're looking at a hospital system, they might have to bill your insurance. And if there's an error in the Social Security, that ends up getting fixed down the line. So we might trust that a little bit more. So these are all things to be thinking about as you're developing your strategy. And once you've figured out which fields you want to be linking on, you'll have to think about what partial fields you'll want to take from those as well. Another very important piece is just how you're going to clean your data. And this is what we saw in the hashing exercise. It's important to have an apples to apples comparison. So if I have a dash in Social Security in one data set and not in another, I'll need to be making sure I'm doing the proper cleaning in that first data set so that we can get the apples to apples comparison. So some example cleaning steps that we've taken in the past for Social Security: removing non-numeric characters, padding with leading zeros if it's less than 9 digits. For names, we'll remove suffixes such as junior or senior, or prefixes such as Mr. or Miss, and we'll often replace special characters. So we'll replace A with an accent with just an A. And birth date, we'll just make sure everything's kind of in the same format. And another piece is just determining what do we consider to be a bad piece of PII. So if something is missing or not available, that's considered bad PII. If it's Social Security, we know there are certain rules about how that's created. So anything that's more than 9 digits long, starts with invalid characters, we would count those as bad as well. Birth date, typically we don't want anything that's implausible. So if the month is 13, that's an implausible date, as well as very early years that seem implausible for our data set. This can be a pretty challenging problem. So if we think about addresses, for example, if we're trying to link on address, it can be difficult to come up with what is really a bad address? So one thing you might think about at first is that the street number should be numeric. But what if you have something like 11A Main Street? That's a valid address. Now, what if you have an agency that stores their addresses just in one field, and you have to extract all the separate fields like the street name, the street number. How can you do that in a standardized way if maybe some street names have spaces, some of the addresses entered don't have, say, street or avenue at the end? You can think of all sorts of challenges that can come with this. And an important reminder is that we can't analyze the data ourselves ahead of time. So we really need to be asking the partner questions about their data and thinking about all kind of the possible edge cases as we're writing the code to do the cleaning steps. And once you have your strategy for what is considered bad PII, we will not hash the bad PII. So we'll replace that to be missing, and we'll just have a flag that says, yes, this was bad. One reason for this is that it simply saves storage space. So the hash strings are very, very large, and we're often working with large administrative data sets. So anywhere where we can kind of save space, that's very important. It can also prevent false positives. Thinking about the hospital example, in some of the health data that we've worked with, some hospitals will write a missing SSN in as 0000. What if hospital A and hospital B both do that? Then once it's hashed, we'd have no way of knowing that these were actually really missing, and we might get false positives out of that. It can also help when you get to evaluating the quality of your match. So if you are seeing pretty low match rates, but you can see from the bad flags from the hashed data that a lot of those things that aren't matching have bad data, that can provide you with a plausible explanation as to why you're seeing such a low match rate. And now we'll dive into the match scoring as well. So scoring is just one way we quantify the quality of a match on a given PII field. So looking at the first name example, the first four letters of the first name will get a higher score than the first two letters. And then it's time to be thinking about your matching rounds. So typically you'll want to think about different levels of confidence that you want to have in your matching rounds. And typically we'll start with the strictest round and work our way, loosen up some of the criteria at each step and work our way to a less strict round. And we'll go over why in a second as well. And you want to end with the weakest level of similarity that you would still consider a match. So you still want that last round to be something that you're pretty confident is a true match. And part of the round definition is also how you're going to treat the bad data in that round. So we have our own defaults that have worked for kind of a variety of administrative data sets that we've worked with. And we found it tends to be a pretty broadly applicable way of doing it to a variety of contexts. And that can either be a starting place if you want to do your own linkage, or simply use our code directly as well. And I'll go into the strategy on the next round. So our exact matching rounds that we consider are, we have 4 separate rounds. So we start with just a perfect match on all of the fields that we have available to us. Then we move on to a perfect match on Social Security and 2 of the remaining fields, with a fuzzy match on the 3rd field. Then the next round is just a perfect match on Social Security and 2 of the fields, but for no requirement on that 3rd field. And the last round that we include is a perfect match on Social Security and one of the other fields. So you can see we start with the most strict and kind of introduce some fuzziness at each stage. But the last round is still a pretty strong round. We have SSN as well as one of the other fields. So that leaves us pretty confident that those are still a match. So the linkage strategy includes the PII fields, a description of how to score each field, how you're going to treat bad data, as well as your criteria for what is actually bad data, and the list of your rounds. And as I mentioned previously, it's critical to do this all before hashing so that you know what cleaning steps you need to take and what partial fields you'll be taking when you hash. And I'll go into a little bit of our linkage code. So the code will output, will have 3 outputs. So the main output is the crosswalk, which is just the mapping of IDs from dataset to dataset that we think are a match, as well as we have a few other things that have statistics just about match rates in each round. I particularly want to highlight the waterfall. I'll show you what that looks like in a second, but it shows you the marginal match number of matches that you're getting at each round. And that's why you want to structure it so you're starting with the going from the most strict to the least strict, so that you can see what the impact is, how many additional matches you're getting when you loosen up your criteria. So this is what the crosswalk will look like in practice. So you'll see the mapping of the agency IDs that you think are the same, and also which round that they matched on, as well as the corresponding score. And you can see in the waterfall how it starts with the strictest round, and then you can see gradually over time the number of matches, additional matches that we're getting at each step is going down. And another important piece is that before actually linking, you need to prepare your data for this step. So some common steps you need to take are renaming the columns so that they're consistent across both data sets. And importantly, you'll need to have that ID from the crosswalk. It needs to be present in both data sets. Not every agency will have their own identifier, so you may need to create your own using a row number or something similar if that is the case. Also, having an ID like that can help you speed things up by identifying cases where there might be multiple matches. Some common things that have come up. The columns in both data sets need to be the same for the fields that you're linking on. So if first name is FN in one data set, it needs to be FN in the other data set. And that's how our code will know that this is the same field in both data sets. An important point is that the code does not restrict the IDs to a single match. So you can have a case where A matches to both B and C, and you have to kind of decide, do I want to keep all of those together and assign them the same identifier, or do I maybe want to just keep the pair that has the highest score? So that's also part of the strategy as well. And with that, I'll pass it off to Karla for the last activity.
Thank you, Sarah. So there's going to be like a 5-minute activity. It's to get you to think about the linkage strategy. So please go to this URL right here. And some folks give me a thumbs up once you're able to access it. So the idea here is that Sarah went over a lot of the things that go into determining a linkage strategy. So you need to think about rounds. You need to think about scores. You need to do a PII inventory. I really like how she pointed that. So it's thinking about the percentage of missingness that you have. You also will have to think about what is considered a bad PII field. And this is really important, especially when you are dealing with, for instance, addresses, right? Like that's a challenge that we have been facing. So I'm gonna exit out of this and share this. Okay. So I just came up with a case. So for a new research project, you want to assess the impact of CalFresh on the health and healthcare outcomes of enrolled birthing parents between 2019 to 2022. And to conduct your analysis, you will need data from 3 agencies. One of them is CDSS, which has enrollment information. The other one is CDPH, which has select birth-related health outcomes and demographics. The last one we call HCI, which has service day, diagnostics, external cause of injury, and more. More importantly, for your linkage, these 3 agencies have the following PII. CDSS has first name, last name, social security, and date of birth. CDPH has first name, last name, date of birth. They don't have a social security, and we do have addresses, but only for part of the time range we're looking at. And finally, HCI has first name, last name, social security, date of birth, and addresses, but the social security, it's missing for 40 to 50% of the data depending on the year. I know this might seem like a weird example, but these are actually real scenarios which we have to deal with when we're trying to deal with linkages. We definitely have instances in which we don't have the same variables across all of them, so we need to think about a strategy to try to create this linkage. So for this activity, I'm gonna have you work with the folks in your table to try to come up with a linkage strategy in 5 minutes. So here are some guiding questions or things that you can think about. And we just put an example of like a match rule, match rules on the bottom. So, are there any questions about the assignment before we begin? Hello, hello, hello. Hi. Hi, folks. Can we come back? So, would you like clap once? Okay. Um, how was that for you? Of course, yeah. What are some challenges you had to deal with? Anyone wants to share challenges or suggestions? It definitely is tricky. We're trying to, get you to solve one of our linkage problems right now. In case you didn't know. The any other thoughts? Yes. 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 Absolutely. Absolutely. That's definitely challenging. Yes. Yes, that's something that we also like deal with. And one of the things that we try to think about is in terms of like one outcomes and two how reliable, like which one is the most reliable to use it kind of as a backup. So I'm not gonna be able to take more great ideas from y'all. But in summary, I think that what we wanted to convey here is that this is a really challenging problem. It's not so much about the code. That's why we didn't bother to show you the code, which is in R. If you want to look at it, you're welcome to. It's more about thinking about the linkage strategy, and you need to think about this ahead of like trying to even ahead of trying to even do it. The last thing you want to do is to go deep into a linkage strategy and then realize that it's not you forgot a bad PII field, or you didn't create the partials that you needed, or the way that you were linking the information, like the order was not actually what you intended. So thinking about these things ahead of time will save you a lot of time, and um, yeah, just would just save you a lot of time down the line. And with that, we conclude. I go back to our beautiful slides. I think the last thing that I think the biggest takeaway from this presentation is that hash linkages can help, obviously, preserve the privacy of the PAI. It can help us break down data silos, which again can help us break down policy silos. And honestly, they're super fun to implement. I recommend all of you to try it. We have our toolkit. Our toolkit is available on our website. You can access that via the QR code or the links. We also have all of our code in GitHub and also the slides for this presentation. And with that, thank you so much, and I hope you enjoyed it.